On this example, we're going to look at how to graph the basic sine and cosine function, but now with the midline and with a change in the period. So let's go ahead and label the amplitude, period, and midline first. The amplitude is the absolute value of -1, which is 1. Now, the negative does tell us something. This function is going to be reflected. We'll address this in a minute. Now, the midline, let's do that one first. Midline is y equals -2. And my period, so the fundamental period for cosine is 2 pi. We have to divide it by the letter in this case, or a number in front of the x, which is pi. So this is 2. So my period is 2, which means that the step size that I will have, well, that is 2 divided by 4 equal parts, which is 1/2. Let's look at our axis and see if this will actually work. Now, on the y-axis, this should work just fine. My midline is -2. I'm going to go ahead and put that down. I'm going to do this in a dashed line just so we don't confuse it with our actual x-axis. So this is my midline. From the midline, the amplitude is 1, so I would go 1 up and 1 down. This should work just fine. Now, what does not work is the actual x-axis labels. The period for our function is 2, but my x has labels in pi's. That doesn't work. So let's go ahead and fix that. So instead of pi, the actual period will be 2. So this is just 2, which means this is 1. This is 3, no pi's. And this is 4. Same thing here. This is just -1, no pi. Now, with that, since 4 squares is 1, 2 squares is 1/2. So my step size is 2 squares. All right, let's see if we can go ahead and put it together. I'm not going to worry about reflection just yet. Let me plot the points without the reflection first as placeholders, and then I will address the reflection. This is a cosine function. It starts at a maximum value. The maximum for this cosine would have been at -1. Again, these are not actual points. These are placeholders. 2 squares to the right, or 1 step size to the right, we will go into the x-intercept, then we'll go into a min, 2 more squares to the right, then x-intercept again on our new x-axis, on our new midline, then into the max, x-intercept, min, x-intercept, and max. Now, if this was the regular cosine function, that would have been it, but it is reflected. So let me address that. Now, the points that are on our new x-axis, on our midline, they will stay. Since the reflection is over this midline, the points that are on the actual line will stay. Now, the max and the mins, they will switch places. So this max is going to go down below into a min. This min is going to go up into a max. This max goes into a min. This min goes into a max. And this max goes into a min. I'll go ahead and erase my placeholders so I don't accidentally connect them. I don't need this one, don't need this one. And I will connect the ones that are left in the cosine curve. And there you go. That is the graph of that function, graphed without the use of a graphing calculator. Let's go ahead and look at the sine function. This is 3 sine of pi over 2x plus 2. Oh, the labels on the top label the max min values on the X and the Y axis. If you labeled your X axis and your Y axis, that is already done for you. So my Y-axis already has labels. This is -1, this is -3. And my X-axis, I have relabeled it according to what the period value is and what the step size is. So really, this is already done for you guys. So we don't have to worry about it. If you're just labeling your graphs, it all should come together nicely. Let's go ahead and look at the sine function. Switch the color over here. So, okay, my amplitude for the sine function is 3. This function is not reflected. The midline, that one will be y equals +2. And then the period, the fundamental period for the sine function is 2 pi. We have to divide it by the number in front of the x, which is pi over 2. Okay, fraction division, 2 pi over 1 times 2 over pi. Pi's cancel. This is 4. Now, since the period is 4, my step size would be 4 divided by 4, which is 1. Now let's look at the labels on the x and the y-axis. On the x-axis, my labels do not work because it's labeled in pi, and I don't want pi. I want my period to be 4. So I'm going to go ahead and switch this to 4. That's one period. 8, that's another period. I need to graph 2 of them. So that means that in between here, this is 6, and this is 2. Okay, what does that mean? Well, the step size is 1, which once again is 2 squares. Now that is because I'm labeling it this way. If I labeled this as 2, then my step size would be 1 square, but I didn't. So we'll go ahead and go with this. All right, now the y-axis. My midline, let me go ahead and graph the midline real quick. My midline is at y equals 2. Oh, I don't want to graph it over there. I do want to switch the labels first. They're not going to work because my amplitude is 3, and if I put the midline at 2, it's just where I'm not going to have enough squares to go up 3. So we'll go ahead and switch this to be 2, this to be 4, and this to be 6, and the same in the negative direction. -2, -4, -6. Now, if I put my midline right here at 2, then my amplitude is 3, so I'm going to have a function that's 3 tall from that spot. All right, let's go ahead and put it all together, graphing it as we go. So the sine function starts at an x-intercept of your new x-axis because you shifted it up 2. And then the next step, so 2 squares to the right, the next step goes into a maximum. Now, maximum has to account for the amplitude, and my amplitude is 3. 1 square is 1 here, so 1, 2, 3, and right here would be my maximum. Now 2 squares to the right will be another x-intercept. 2 squares more to the right minimum, so remember I have to have 3 here. The amplitude is 3 between the new x-axis, this dashed line, and the maxes and mins. So right here's your min. 2 squares to the right is another x-intercept. 2 squares to the right is another maximum. 2 squares to the right is another x-intercept. 2 squares to the right is another min. And 2 squares to the right is another x-intercept. Connect the dots in a sine curve. As pretty as you can. I'm looking for no sharp corners here. All right. This is it.